Merry Christmas and a very warm welcome to each one of you again to our channel Study Quiz. Today we are going to do another topic from the series that we were having. The topic today is probability, and this I find to be one of the easiest chapters that you have in class 11. You have got this chapter in class 10th as well. So maybe something is there which is a revision for you, and something will be there which is going to be added in your syllabus this time. So why to wait, and without any further delay, let us quickly start with it. And before starting with it, let us just a little bit disclaimer that if you haven't subscribed to our channel, then please do it, and if you haven't pressed the like button, then please do like, share and subscribe to our channel Study Quiz. Okay, now let us quickly start with this chapter, that is probability today, and we are in a good mood today. It's Christmas, and so we are starting with this chapter so that it's quite easier to do. Okay, so now in this I have written over here certain terms, and before when you start and when you solve the questions related to probability, the most important thing is that you must be knowing, that you should be knowing actually, the terms which are there, what do they mean. That means the theory for this chapter is very important, then the questions are very easy. Okay, so first of all we'll be seeing what is a random experiment. What is a random experiment? First of all is random experiment. Random means at random we perform certain things, means like just like that. So that is random. The term is random experiment. This is experiment. Yeah. So we have got random experiment, and random experiment means at random performing any experiment. For example, I take a coin and I just toss it. So that is a random experiment. At random I am doing something. I took a dice or a die as you call it, and then I am tossing it. Then that is a random experiment. Okay, so that is a random experiment that we have. Second thing is sample space. Now what is a sample space? So when I perform any experiment at random, then whatever possible conditions I can get, that is basically the sample space. That means the first example that we took was for the coin, right? That means if I'm tossing a coin, you all must have seen a coin and must be knowing also, like one part is the head part and the second one is the tail. That means if I toss a coin, there is a chance that I can either get a head or I can get a tail if I am tossing it once. So that means this head and tail, this becomes my sample space. Sample space means total number of possible conditions that could be there, total number of possible outcomes that I can get, that refers to the sample space. So I hope that this part, the sample space, is very much clear. How to write a sample space? Then with the help of these curly braces, we write it, and each term that is there or each possible condition or outcome separated with the help of commas. So I hope this part is clear now. This is how we represent a sample space. For example, I am taking a die or a dice and then I throw it at random. Then what will be the possible condition that I can get? When it is a die, then I have got 1, 2, 3, 4, 5 and 6, right? These are my possible conditions. भाई अगर डाई को थ्रो करते हैं, then यही तो मिल सकता है 1, 2, 3, 4 or 5 or 6. That means out of any of these I can get 1 if I am tossing a die 1. That means my sample space then becomes, I will be writing these terms within these curly braces, and this becomes my sample space. So this part is clear, the sample space. Now event. Event is not something that is quite difficult. See, what is event now? When I throw a die once or a coin once or any such thing for the matter being, then whatever thing I can get as a result, that is said to be my event. That means if I toss a coin or say a die, then I can get 1 as my answer, 2 as my answer, 3 as my outcome, 4, 5 or 6. That means the condition that I did, that means I have thrown that or I have tossed that coin or the die, then that becomes my event. Okay, that becomes my event. That means if I am getting 1 or I am getting 2, then that is my event. That is happening of something. Happening of a certain condition is known as event, right? Like we have the event parties and all. These are events that we organize. That is an event, right? Now another thing is impossible event. Now, if I toss a coin, then I say that let me get 1. Is it possible for me to get one number that is there if I toss a coin? No, I can either get a head or a tail. That means that is an impossible event. Now, in the same condition, if I toss a die and then I ask you to tell me the probability. What is probability? That is the possibility of an event. Probability, another term for probability could be possibility. That means possibility of an event. Now, impossibility of an event means that event cannot happen only. That means if I ask you to toss a die and then I ask you to tell me that what is the probability of getting 7. Say 7. Now when I toss a die, then I am having numbers till 6 only. Then how to get 7? Therefore that becomes my impossible event because that is not possible only. So that is an impossible event where we cannot find out any such condition. Any possible condition is not possible over there. That is an impossible event. And the probability for an impossible event will always be 0, definitely. If that is not going to happen, then it becomes impossible and so the probability is 0. Now, after that we have equally likely outcomes. Now, what do we mean by equally likely outcomes? Then, by the name itself, just look at the word that is there. I have got equally likely outcomes. What is an outcome first of all? Outcome is the result. That means whatever condition event that is there, so that is an outcome. Now equally likely, that means one is happening and the other is happening. That means equally likely means like if I toss a coin or a die, then there is an equally likely possibility that I can get either a head or a tail. That means no preference is given to any one condition or any of the conditions. No preference is given to any of the conditions, and so whatever be the possible outcomes, all of them are possible. Whatever be the total number of outcomes that are there, they are all possible. That means I have not given any preference to any one condition or any one or two condition for the matter being. Okay, so that is equally likely outcomes. That means if I toss a die, then I have equally likely possibility that I can get either of the numbers from 1 to 6. That is equally likely. That means anyone can happen and there is no preference to anyone. That means only 6 will come or only 5 will come. Can I say like this? No. If I toss a coin, then can I say that I'll be getting only head and head and head? No. Head or tail, any one of them can occur. Right? So that is equally likely outcomes. No preference given to any of the conditions. That is equally likely outcomes. Now exhaustive. By the name itself, exhaustive. Exhaust means that something that can exhaust, something that can finish. That means when my events are exhaustive, that means if I take one event and the other event and the possibility that is there or the probability of both of them, if I combine, then it becomes complete. That means there is nothing which is left apart from the probabilities of these two events. Let us take an example, same example we are working with, because so that it becomes easier for us to understand, right? So we are taking a die example again, or let us take a coin example now. So if I say that the probability of happening of H, that means head, is 1 by 2, then the probability of happening of tail will be 1 by 2. Now see, how to write, what is the probability first of all, how to write it. So whenever I am saying that I have to find out the probability of 3, let us say 3, what is the probability of 3 when I toss a die once, so when I throw a die once, then we write the number of favorable outcomes which are there, number of favorable outcomes upon the total number of outcomes which are there, total number of outcomes. Therefore, it is a fraction. Probability is a fraction. Let me write it down there. It's the only formula that you have to remember. No, you will be getting more. Wait. Okay, so what is the probability? How to find it out? Probability means the number of favorable outcomes which are there. That means the condition that has been asked in the question and all the outcomes which are going to satisfy that condition will be a part above here. Probability represented with the help of P generally, and let us say probability of A we are finding out. That means P of A, then that is equal to what? Favorable outcomes upon the total number of outcomes that I have. So total number of outcomes which are there. Favorable number of outcomes actually. Number we are supposed to write. Okay. This is the formula for the probability part. Favorable number of outcomes upon total number of outcomes. No. Now we were taking the example that was for a die or a dice. So what is my sample space within the curly braces? 1, 2, 3, 4, 5 and 6. This is my sample space, isn't it? Now from this sample space I want the probability of 3. Now this 3 is there when I toss it once. When I am tossing my dice once, that means I can get either of these numbers. Therefore total number of outcomes will be 6. Bhaiya, I can get any one. 1, 2, 3, 4, 5, 6. And favorable is 1 only, that is 3. Favorable is 1 only because once only I am tossing. If I would have tossed it twice, then my condition could have been different. But right now when I am tossing it once, then only once there could be the possibility that I can get a 3. Therefore the possibility of this event that is occurring of 3 becomes 1 by 6. So this is how your probability comes. Okay, this was the formula for it. So that means I was explaining you the exhaustive. Yes. And now we take an example of a coin. Sample space for coin becomes head or tail. When it is thrown once, I can either get a head or a tail. Probability of head, let us quickly find out. Probability of head, what will it be? 1 by 2 because total outcomes are 2 and favorable is head only. Once I can get head, that is 1 by 2. Then probability of tail could be again 1 by 2. Now when I sum up them, then it comes out to be 1. Is it coming 1? Yes, this is coming 1. That means this was one event, this was the other event. Total outcomes were 2. Okay, 2 times I can get them, and when I added them I got 1. That is complete. Therefore it becomes exhaustive. That means if I took head and tail, when I am taking out the probability of them and summing them up, it becomes 1. That is complete. 1, or in percentage if you want, then it comes out to be 100%. Therefore that is exhaustive. Exhaustive means when you sum up the probabilities, separate probabilities, and you get 1, or if you are not getting 1, that means there is something else which is a part left out. Okay, that is an exhaustive one. Okay, now after this you have mutually exclusive. Mutually exclusive, clearly by the name itself it suggests you, that means if one is happening, then at that point of time when that same is happening, the other one cannot happen. How come? If my head is occurring once I tossed my coin, if I am getting a head, can I get tail also? No, absolutely never. Because if I get a head, then how can I get the tail on the same side, same tossing? No, I cannot get. Therefore, they are mutually exclusive events. They are mutually exclusive events. Over here, if I ask you to get 3, then I can get 1 by 6 the probability. But if I get 3, then I cannot get 4, 5 or 6. Any of these numbers together with 3 if I toss it once. Therefore, they are mutually exclusive. But at the same time, if I ask you, let us assume that the question was the finding out the probability, in this case, finding out the probability of multiples of 2 and the probability of multiples of 3. So first of all, multiples of 2 we will be seeing. Then what will be the probability quickly? Multiples of 2 will be 2, 4 and 6. Therefore it is 3 by 6, that is 1 by 2. And probability of finding the multiples of 3 would be 3 and 6. Therefore it is 2 by 6, it is 1 by 3. Okay, now see. Here my outcomes were 2, 4 and 6. Over here I am having 3 and 6. Is something repeated? Yes. My 6, if you see over here and over here, then the 6 is repeated. That means if this is happening, then a part of this is also happening. Therefore, these two are not mutually exclusive events. In the previous case, we were taking 3 and any other number, once tossing the die, they were mutually exclusive. But over here, these events are not mutually exclusive because the condition for the happening of mutually exclusive events is that when one is happening, the other one should not happen. There we are having something in intersection. Intersection means something which is common to both of them. Okay, so I hope this part is now very much clear. The mutually exclusive events. Yes, I am coming to that intersection part also now. Now we come to the algebra. Algebra of solving these probability questions only. Now before starting with the algebra part, let me just tell you the total possibility could be 100%. You cannot get above 100%. Can you get above 100%? No. So the total possibility of any event could be, total outcome that could be, the total will be 100% and the minimum could be 0. Below 0 you cannot move. 0 will be when we'll be having impossible event. Okay, and when you sum up their probabilities of total one, that means if probability of A is there and probability of B, it will come out to be 1 always. Summation will come out to be 1. Okay. Now coming to the algebra. In the algebra we have got the union, intersection and the complement part. First of all, the union. We have studied this thing in the sets portion. Similar is the concept. Nothing is there which new introduced over here. So that means probability is there. The only difference that it makes is now the probability sign. Okay. So probability of A union B, that will be probability of A plus the probability of B. I hope this part is very much clear. Now this is the condition when they are mutually exclusive events. Please mark it, when they are mutually exclusive. Right now only we have studied what are the mutually exclusive events. So when these are mutually exclusive events, then you have this as the probability. Now when they are not mutually exclusive events, that means they have got something in common. Then remembering and reminding ourselves, recalling the formula that we did in the sets portion, that was P of A, that means possibility of A plus possibility of B minus times the possibility of A intersection B, that means A intersection B is the common part. Something that is the part which is common to both of them. So this was the formula that we were having for the union one. Okay, I hope this part is clear. So when they are not mutually exclusive, using this one. When they are mutually exclusive, that means when one is happening, the other one cannot take place. Then we have this formula. There is no such formula as we are studying over here. It's just a simple logic that you have. Okay. And this together will come out to be 1 when they are mutually exclusive and exhaustive. So if they are mutually exclusive and exhaustive, if this is the condition given in the question, then this together will come out to be 1. Otherwise, if it is not exhaustive, then it will not come out to be 1. That means there will be some possibility. That means some other event can also take place at a different time. Okay. So this part is clear, that is a union part. Intersection is, I hope that part is also very much clear, that whenever you are having something in common, then that is intersection part. So how to calculate it? With this formula only you can get it. Like the question that we studied, that was for the 2 multiples and 3 multiples. There you were having 1. One thing was in common. So there, with the help of this formula, you can get 1 by 6 as the probability that will come for the intersection part. If you want, then you can solve it out also. Okay. Now we have the complement. Complement is, what is a complement? Complement we have studied in the set portion also. That is basically the not happening, the probability of not happening of that event, or the negative of an event is known as a complement. That means possibility of A is represented like this, and if I ask you to find out the probability of not happening of A, then I can write it as this with a comma over here, or I can represent it with the help of bar. This is probability of not happening of that event, that we write as the probability of a complement. Okay, that complement part is also very simple. And the probability of an event A plus the probability of not happening of that event will be equal to 1. Okay, this thing you can remember. So this algebra part is done. Now we come to the diagrams. This is something like we are playing with the things. So this is the diagrams which are there. So how to represent it with the help of 3 types of diagrams you can represent. One is a tree diagram, the other one that you have is the space diagram, and the third one that you have is a Venn diagram. Venn diagram similar as the set theory. Then the first one that we have is the tree diagram. Quickly seeing the tree diagram, it is nothing. That means if I... Okay, now before starting with these diagrams, let me just tell you one more thing. That is basically when you toss a coin tossed once will have two probabilities, head or tail. Right? Now if I toss, this is one time when I am tossing the coin. When I toss a coin two times, then what can be my probabilities? Once I can get head or I can get tail. Right? Once if I am doing, then either I can get head or I can get my tail. Now after getting this head, when the same coin is tossed again, I can again get either my head or my tail. Okay? And over here also I can get either my head or my tail. Is it clear? Therefore, how many possibilities am I having? I am having 1, 2, 3 and 4. 4 possibilities. Over here I was having 2 possibilities. Right? Now let us see for 3. If we toss 3 coins, that means once I can get head or tail. From this head I can get either head or tail. From this tail I can get head or tail. This is the second time. First time this is there. Second time I am getting these outcomes. Now when this toss third time, then I can get with this head I can get head or tail. With this tail I can get head or tail. With this head I can get head or tail. With this tail I can get head or tail. How many total outcomes? Quickly seeing 1, 2, 3, 4, 5, 6, 7 and 8. So 8 possible outcomes I can get if I am tossing this same coin thrice. Tossing the same coin thrice or tossing 3 coins at the same time makes the same thing. It's one of the same thing. Okay. So now I can write this as 2 raised to the power 1, this as 2 raised to the power 2 and this as 2 raised to the power 3. That means if my total possible outcomes were head or tail, that means 2 possible conditions were there, then I was having 2 raised to the power n, where n was the number of times the coin was tossed or the number of coins that were tossed. So my total probability was coming 2 raised to the power n. Similarly, if I take a die, now this was for the coin that I explained you. Now seeing for the die. When I have a die, then one time tossing a die, I can get 1, 2, 3, 4, 5 or 6 as my possible outcomes. So my die is there now. One time when I am doing, I can get 1, 2, 3, 4, 5 and 6. Therefore 6 possible outcomes I can get. Now when I am doing it twice means 1, 2, 3, 4, 5 and 6. This is one time. Now with this one, I can get 1, 2, 3, 4, 5 and 6. With this 2 similarly I can get 6 outcomes. With this 3 also 6. With this 4 also 6. 5 also 6 and 6 also 6. Therefore 6, 6, 6, 6, 6 and 6. 6 6 the 36. So when you will do it for thrice, when it is done thrice, that means over here it was 1, then similarly 6, 6, 6, 6 you will be getting. So 6 into 6, 6 into 6, 6 into 6, 6 into 6 into 6. That means 3 times you will be doing, that is 6 raised to the power 3 you will get when you will be doing it thrice. When you will toss or when you throw a die thrice. Therefore, when my 6 outcomes were there, I was getting the probability as 6 raised to the power n. This is there. Okay. So this is the thing that you need to remember. Whatever number of outcomes you can get when tossing it once, that same number raised to the power, the number of times you toss that same thing or the number of things, number of, number of times that you take that thing. Okay, so that will be 6 raised to the power n is over here, and in case of die in case of coin we were having 2 raised to the power n. So I hope this part is clear now, that what will be the total possible outcomes are this. That means if I want like 2 times my die is thrown, you'll be getting questions related to it. Then you'll be writing the favorable outcomes upon total number of outcomes will be 36 always. Okay, and when it is 3 dice, generally you will not get the questions of 3 dice, but if you get, then you'll be writing below. In the denominator part, you'll be writing 216. 6 raised to the power 3, that is equal to 216. Okay. Yes. So this diagram that you have, like this, if you represent, this is nothing but the tree diagram. Like a tree branches you are showing over here. Therefore, it is a tree diagram. Sample diagram is there. Space diagram actually. That is nothing but simply writing it down. Space diagram, I will show it to you. Although it's not like very much. Leave it. Let us just see to it what is there, and then we'll move to the Venn diagrams. I won't be explaining the Venn diagrams because we have already done them, right? Space diagram is like this. Now head and tail is there. Once you can get them, second time you can get head and tail. Like this you are supposed to write. Head tail you can get head tail tail and tail head. 2 times tossing a coin. 2 times tossing a coin, you will get this. This is the space diagram. If you toss it once only, then you write it like this only. Okay, one time they don't ask you. They don't ask you for the space diagram at all. Okay, then third one that you have is the Venn diagram. So Venn diagram, you know how to represent it with the help of circles. You will be writing when it is universal set like this. If something is there in common, then represent it like this. And this is the intersection part. A intersection B. Probability of that. This is the probability of A, probability of B, and this is the intersection part. And total will, you know how to write. This is the universal part. It is the probability of it. Always a probability. This is the Venn diagram you have already done. Okay. Now measurement is there. So measurement of probability, I already explained you what is a measurement. That is basically probability of an event is equal to the favorable outcomes upon which are there upon the total number of outcomes that could be possible. Okay, so that measurement is there. Total probability will be 1 always. Then the minimum probability could be 0 when the events are impossible, right? That was there. Probability of an event plus probability of not happening of that event will be equal to 1. Okay, so this measurement part is done. Now coming to the thing that you haven't done in class 10th, and that is the odds. Now odds, it is also something very simple. With a name you can remember it. Now when we are writing odds, 2 conditions will be there. Odds in favor of, and second condition will be there, odds against an event. Okay. Now when the question is odds in favor of, then you are going to write, भाई नाम समझ में आ रहा है, फेवर में पूछ रहे हैं, तो फेवर में पूछने का मतलब है कि जो हमारी फेवरेबल कंडीशंस है उनको ऊपर रख देंगे और जो अनफेवरेबल कंडीशंस है उनको नीचे रख देंगे. ओके, देन द रेशियो जो हमको मिलकर आएगा दैट इज नोन एज द ऑड्स. सो ऑड्स इन फेवर में क्या होगा, हमारे नंबर ऑफ फेवरेबल आउटकम्स जो है आउटकम्स अपॉन जो अनफेवरेबल आउटकम्स हैं. आई होप दिस पार्ट इज क्लियर नाउ, राइट? फेवरेबल आउटकम्स क्योंकि हमसे फेवर में पूछ रहे थे. अगर फेवर में पूछे हैं, दो चीज पूछेंगे वही तो ऊपर रखेंगे. तो फेवर में पूछे हैं तो क्या रखेंगे, फेवरेबल आउटकम्स अपॉन अनफेवरेबल आउटकम्स. और अगर हमारे पास ऑड्स अगेंस्ट में पूछ रहे हैं तो अगेंस्ट में क्या मतलब हो गया कि जो अनफेवरेबल है उनको ऊपर रख दिया, अपॉन जो फेवरेबल है उनको नीचे रख दिया. सिंपल. एंड इससे कंफ्यूज नहीं होना है प्रोबेबिलिटी से, बिकॉज प्रोबेबिलिटी में क्या था, फेवरेबल तो रख रहे थे लेकिन नीचे रख रहे थे ना टोटल नंबर ऑफ आउटकम्स. यहाँ पे टोटल में से माइनस कर दिए फेवरेबल को तो हमको मिल गए अनफेवरेबल. यानी कि अगर मान लेते हैं टोटल प्रोबेबिलिटी क्या होगी, 1 ही होगी हमेशा, राइट? अगर मान लो फेवरेबल आउटकम्स की पॉसिबिलिटी जो है वो हमारे पास है, लेट अस अज्यूम 1/4. कैन देयर बी 1/4? यस, 1/4 हो सकती है. ओके, फेवरेबल की हमने मानी कि 1/4 है, तो अनफेवरेबल की क्या हो जाएगी, टोटल प्रोबेबिलिटी माइनस 1/4, दैट इज 4 - 1 दैट इज 3/4. ये क्या आ गई, अनफेवरेबल की. तो फेवरेबल की कितनी थी, 1/4, अनफेवरेबल की कितनी है, 3/4. इसको सॉल्व किया तो क्या है हमारे पास, 1/3। तो ये हमारा क्या आ गए ऑड्स उसके फेवर में। अब हमसे पूछे हैं ऑड्स अगेंस्ट में, तो ऑड्स अगेंस्ट में क्या होंगे, अनफेवरेबल को ऊपर रखना है, डिवाइडिंग बाय द फेवरेबल। अनफेवरेबल क्या थे 3/4 अपॉन फेवरेबल क्या निकाला हमने अभी, इट वाज ऑलरेडी गिवन 1/4, इसकी क्या आएगी 3/1। दैट मींस यू कैन सी रेसिप्रोकल है, क्योंकि हमने रेसिप्रोकल क्यों होगा, क्योंकि ऑब्वियसली रेसिप्रोकल ही आएगा भाई, रेशियो चेंज कर दिया अगर ऊपर नीचे देन क्या होगा रेसिप्रोकल आएगा। दीज आर ऑड्स, तो इसमें कंफ्यूज नहीं होना है। प्रोबेबिलिटी में नीचे में टोटल नंबर ऑफ आउटकम्स ले रहे थे, पॉसिबल टोटल ही जो पॉसिबिलिटी है हमारे पास, यहाँ पे क्या है फेवरेबल तो लेंगे लेकिन उसके नीचे लेंगे अनफेवरेबल। अगर पूछा है odds in favor of, अगर they are asking you odds against, then you're going to write unfavorable upon the favorable one. So please don't be confused with this thing, and there is nothing that is of confusion here. By the name itself it is clear. Against they are asking, so unfavorable first. In favor they are asking, so favorable first. Okay, so odds is done. Then yes, these formulas are there, I already explained you. Once again I can write it down for you. That is basically probability of A union B. Probability of A union B will be equal to probability of A plus probability of B. But when these events are mutually exclusive, if they are not mutually exclusive, so they are mutually exclusive. Let us write ME. And when they are not mutually exclusive, NME. See, enemy. So when they are enemy, then they are P of A union B becomes P of A plus P of B minus the probability of A intersection B when these are not mutually exclusive events. Okay. Now another formula is there, when you have got three events together, then the possibility that they are asking you for the A union B union C is nothing but the set formula, that is P of A plus P of B plus P of C minus times P of A intersection B minus times P of B intersection C minus times P of A intersection C plus times P of A intersection B intersection C. This is when they are not mutually exclusive. It is enemy when they are of each other, enemy. Okay. And when they are mutually exclusive, then simply P of A plus P of B plus P of C. Simple it is. Okay. So coin is done. Die we have already seen how to get the possible outcomes for coin, for die. Now coming to the last part of this chapter, that is the cards. Now let us play with the cards now. Okay. So cards we'll be seeing. We are not going to play with the cards, huh? That's bad, don't have to do that. But we'll be solving the mathematics questions related to cards. How to solve them? I'll be just drawing a chart for you. Then you will be able to solve. Now please see, you can learn it. It will be helpful for you if you even play it. So this is how it is. First of all, total number of, it is called a deck. What? DECK, deck. Like we have a group, you must have studied in the nouns, collective nouns and all that we write. This is a deck of cards we call it. Okay, so we have got total number is 52. How come 52? We'll be seeing. Okay, so the first two that we have is the spade, the club. I made a mistake, I should have made it with the blue one. Anyways, this is heart and your diamond. Now see, spade and club are black cards. These are black cards. I have written with the black only. And heart is red and diamond, it is pure, therefore it is also red. So heart and diamond are red and spade and club, these are black cards. Okay, the first card that you have for all of them is ace. Ace, you know, 1, ikka, ace. So ace is the first card. The second one you will be having 2, 3, 4, 5, 6, 7, 8, 9 and 10. Up till 10 for all. 2, 3, 4, 5, 6, 7, 8, 9, 10. Similarly